Good evening, everyone. Welcome to Austin. My name is Jeff Chern from Pivotal Data, TX Data Transformations. Hi, friends. So today I'm going to present something about data serializations and CI/CD technique for Apache Geode. I have been working on a lot of Apache Geode or Gemfire or PCC, Pivotal Cloud Cache project. A lot of time that the challenge I run into with the project is for applications or the system to be able to serializing and deserializing the data between the client and the server. So the goal of this session is to go through some of those challenges or maybe be able to answer some of the questions that be able to help or improve the developers or DevOps experience, and also to improve the quality of the CI/CD pipelines. So let's give a little bit background. Gemfire, before the Gemfire was open sourced, when it was still in the legacy mode, when we working in the data center environment that tried to configure the Gemfire cluster, the technique that we are using, and as mentioned many times before, during the previous session, is the configuration is based on the cache.xml. So to configure the Gemfire cluster, the technique that you have to do is per node configurations, where every node, if you need to make a change, the change has to be applied independently and individually on any given server node. So from the operational perspective, or from the day two operation perspective, anytime you need to make a change, you have to restart the node, one server node at a time. So that's where the legacy coming from. But as the industry keep moving forward, we started getting to the cloud era, right? So it first started from the infrastructure as service or virtualized environment. And as the industry is moving forward, same thing as Gemfire or Geode in that sense. So when Gemfire was open sourced into a Geode, Apache Geode community, there's a feature was enabled at that time, is something called the cluster configurations. So since then, Geode provide opportunity or features allow you to configure your cluster in a more holistic point of view, where you don't have to make a change to a single node at a time, where you can apply the change to the entire cluster through the CI/CD or command line friendly tools, be able to make a cluster change without the need of restarting your cluster or restarting your server node, which give the developers or operator a lot of benefit, in the sense that if you have huge cluster and you have to make a change, such as like creating a regions or making registering of or making a change to index, you don't have to make a XML change and restart your node, which can be very cumbersome and very just a lot of overhead. As we continue, as the industry keep moving forward into the platform as service era, right? Where as a developer or as an operator, I really want to be able to focus on my applications or bring the business values to the system, to my code, without have to worry about too much to the underlying infrastructure or how the service is actually being managed. I want to be able to work in an environment that I'm enabled to do a quick and fast development. That's where the platform as service comes into place, where as I need to have a cluster, I can just say, create a cluster on demand, and the service is readily available for me, and I can code right away. That's where we have been hearing a lot about the cluster management that Geode is coming into play. That actually will be able to help the companies or the platform team to be able to create a service that we should be able to manage and provision in a very easy way, where that's where we start getting into something called cloud native. So one of the examples that we've also been hearing about is like Pivotal Cloud Cache. That's the goal of the SIS platform, is be able to provisioning and be able to use right away without have to worry about too much on the operation aspect. So in theory, right, if we've done everything right, as a DevOps engineer, I should be able to start to write my code and just focus on business rules, bring the values, and then my day two operations from the CI/CD pipelines perspective, from the automation perspective, Should be simple, should be easy, right? Everything should be good. I should be happy. But in reality, as potentially for people are new into Geode, using a Geode in the first time, or maybe using Geode for quite a bit, in reality, we all run into those kind of questions. Why my applications are not running at lightning speed if it's just simple CRUD operations? Or such as when I'm making a data model change, what's going to happen to my cluster? Do I have to deploy the code to the server side, making data model change? Do I have to restart my cluster? What is the operation overhead that's involved when we're making those change? And how, what are the things we have to watch out, right? So to answer those questions, or at least help us to get one step closer to cloud ready, maybe not cloud native yet, but let's say be cloud ready. There's one very important aspect we have to understand. We need to understand how Geode manage the data serialization, what's the context around it. Because Geode is Java-based distributed system, right? Any data comes in and out of the JVM require the data to be serialized and deserialized. And there's implications of how, there's an implication to the application implementation styles and also application performance, all the way up to day 0 to day 2 operation aspect, if we are not handling the serialization and deserialization proper within Geode. So we're going to talk about a little bit for the Apache Geode data serialization fundamentals. So I'm not going to get into like very technical depth about in the code-wise how serialization actually happens, but just fundamental concept that can help us to move forward. So out of box, Geode supports 3 types of data serialization just out of box. So the first one, of course, is basic regular Java serialization. Java serialization can think about if you have a Java class, you want to implement Java serializable. So that's just out of box, it's Java, basic Java stuff. And then we also have something called Geode PDX. PDX stands for Portable Data Exchange. So we also have a support, that's another serializations. And then there's another one, it's called the Java data serialization, Geode data serialization. That's the actual name called the Geode data, right? So out of all those 3, there are pro and con for each type of serialization technique. For Java serializable, we all know it is actually not the best way of doing serializations. If you have other way you can implement. The reason is Java serializable, first of all, it has performance issues. That serialization and deserialization can cause a performance concern. It's not the best way of doing serializations. Another aspect is the usage. So usage is very simple. Java serializable, we all know how to use it. It's very simple. However, from the compatibility perspective, it's actually limited. So if you actually go out to Google and search for Java serializable compatibility, you'll be able to find a documentation from Oracle website. It actually tells you what are the limitations and what are the capability of compatibility for serializing and deserializing when you have data model version change. So there's a limit to that. Then we also have Geode Portable Data Exchange, Geode PDX. This actually is an improvement on top of Java serializable, where it's actually very simple to use, very easy to configure, and it actually has a lot of, it actually give you the best compatibility ability of, for example, be able to work with native client, like what Charlie's session talked about the .NET native client. You can actually be able to use for those kind of use cases. And then performance is just better than Java serializable and very simple to use. Then we'll have Geode data serializations. Geode data serialization actually give you the best performance. The reason is you have a control of how actually data is going to be serialized to and going to be able to deserialize from. You actually have to write a code to handle that. It gives you the best performance, however, because the code you actually have to put into place, it actually is also more for the use case, more advanced use case. If you actually have the business need, you want to work for every millisecond count. I want to squeeze out every possible performance, and then you just think PDX data serialization is not good enough for you. For those kind of special use cases, maybe you can go to Geode data serializations. The concern is just a lot of coding you have to put in place. From the compilability perspective, because you are owning of how you want to serializing and deserializing the data. So that means compilability, you also have the control on how to handle that. You might have to write a whole bunch of if-else kind of statement, but it's customized and you own it. It depends on how much code you want to put into place to get it to work. So because of Java serializable give you the worst type of performance, even though it's simple to use, but the compilability is very limited. So in this session, we're going to focus on just Geode PDX serialization compared with Geode data serializations. So I'm not going to get into the actual example code, how to implement PDX serializer or data serializer. I'm just going to have very high level comparison between the two serializations. So the Geode, the PDX serializations give you the best performance on the deserialization aspect. The reason is if you configure the Geode cluster in a way, say, when I'm reading the data, I want to read the data in serialized format. I'm not going to deserialize every possible attribute of your data model. That gives you the possibility of improve your application performance if you don't have to read every attribute of the domain model, right? And now another thing for PDX serialization is fully supported by the cluster configuration. So we talk about cluster configurations is we can make a code, we can make a configuration change to apply to entire cluster without going to each individual node to make a change. That's where this comes into play, that you can make a cluster-wide change and then it's just going to take effect. You don't have to worry about how each node works. And then, of course, we have very strong support of PDX serializations from Geode and Spring Data Geode perspective, because we actually have out-of-box implementation of serializer. So that means you don't have to implement your own serializer. If you're okay to say, I want to improve my development experience of trusting the out-of-box implementation rather than do my own customizations, that's a trade-off you can take, is taking something that's out-of-box, but you're not squeezing every possible performance out of it. Then PDX works great from the out-of-box serializer perspective. And also, the PDX serializations give you one of the best compilability perspective, both from client and server perspective. So you can actually create a data from the client side and data using PDX serialization and say, I'm not going to deserialize on the server side. Then you don't even need to have the data model on the server side when you try to access the data. So one of the questions is, if I put the data from the client to the server, I want to use the tool to query on the server side. How can I avoid not to getting the error? So this is one of the configurations you can say, using PDX and reserialize equal to true, then you can use a tool without getting all kinds of exceptions like class not found exceptions or potentially class casting exceptions, so on and so forth. And data model change does not require you to restart the cluster if you actually want to deploy the model to the server side. Now, on the flip side, Geode data serialization, it gives you the best performance on serializing the data. When you want to serialize the data and send the byte array or the bit out of JVM into the cluster, serializations aspect from data serialization give you the best performance. I believe from the documentation, it says about 25% better compared to PDX serializations. That's if you have those kind of use cases based on the performance, that's what you're going to get. However, data serialization has minimal support from the cluster configuration perspective. Most likely you have to work on the cache.xml and make a configuration change, so on and so forth. There's no out-of-box implementations, right? And the data model has to be on the class path, or serializer and serializable. Those components have to deploy to the server side. And because there's no cluster configuration supports cache.xml, so which means if you're going to make a change, most likely you have to do a rolling restart, startup cluster. So that's why, based on what we have talked about, right? I personally, my personal opinion, I think there is something called the serialization magic setup. If you want to have a convenient, improved DevOps experience and simplify your day-to operations, and you're not looking for like the 1% special use cases where I need every possible performance improvement in my configurations and setup, I will recommend to start with Spring Boot and Spring Geo Starter, and then just enable the Geo cluster configuration rather than using cache.xml, right? That's something we're going to keep on pushing. And then using PDX as your data serializations. Now, of course, using the out-of-box serializer implementation, something we have is called reflection-based auto-serializer. Then configure your deserialization strategy to say, I'm allowed to read serialized data as I'm accessing data from the server side. This will give you a magic setup. It's going to be very simple to use for your geo cluster type of implementations. But now there's a question, right? If I don't have to deploy the model to the server side, then how do I access the data? If I actually have a server-side component, such as functions, I implement the functions. That function has a code need to access certain attribute and data from the data that's been stored in the regions. How do I do that, right? If I don't have to deploy the model. So here's just examples of how simple the code can be to access the data from the server side. So on the left-hand side, if you just have, assuming you have PDX enabled, you have read serialize equal to true. From the client side, just very basic, straight up, you have domain model or model class, and you set it up and do region.put. On the server side, when you get it out, however, because you say, I want to read data in a serialized form, so it will not deserialize into a domain model for you. So what you're going to get is you have to access with something called a PdxInstance. That's what you're going to get. And PdxInstance is a generic type of data structure. It's very similar to map, right? So you have attribute that's in the field name and the value as a value. So for example, if I want to get bar attribute out, you're going to say PdxInstance.getField and bar and get it out. Of course, there are some disadvantage of taking this approach. The reason being it's not strong type. There's a potential of like typos and hard to test that you're not going to be able to get the potential to get the wrong field out. So then there's another way, thinking about another way is, what if we create a using factory pattern, or in the example I'm giving on the right hand side, just a very straight up of creating a constructor. You're going to create a constructor that's going to take PdxInstance, right? Then you do all your necessary mappings at one place, or you can create a factory patterns, be able to generate your domain models. Then on your server side, then you still can take advantage of be able to work on the strong type, right? And still taking all the advantage of reserialized without the need of restarting your cluster if you actually want to deploy the model to the server side to do the strong type programming preference. So this is what I call the Apache Geode cloud recipe. So we can follow the serialization magic setup. Then, if you have a server-side functions or server-side component you want to deploy, and then you still want to follow the strong type programming practice or preference, Then you can actually create a constructor that be able to handle the PdxInstance. And then you can actually using gfish, that's a tool that we are providing and works with cluster configuration. Then you say, using gfish to do hard deploy. By doing that, there's no reason or no way that you need to do a cluster restart. So now this is really giving me the benefit of my application still perform well, relatively speaking compared to Java serializable, right? And then you still be able to take the advantage of working on strong type. Right? And then you can use the tool without error, and it simplifies your CI/CD process. So I'm going to do a very quick demo. So the very first one is how to automatically push the cluster configuration from the client to server. So one of the topic we want to talk about today is like CI/CD technique. To me, the CI/CD technique, the simplified CI/CD technique is if I can minimize the step I need to do operations, that is the best way of simplified CI/CD. The less I need to do, the better it's going to be. So for example, I have a client applications. So first of all, I want to show I have a cluster. It's a fresh cluster. You have all the nodes. So I'm going to show example is it's a fresh cluster, it doesn't have any regions. And then I have applications, 2 API that's already running. One API is called V1, Customer API V1, and I have another API is Customer API V2. The difference between those two API is actually the model. So the V2 model has one field, one extra field. It's called the date of birth. And of course, it has first name, last name, and ID. Then API V1 has the model of not a date of birth. So first of all is I can actually have my application, Spring Boot application running, connect to the cluster without the need of me creating a regions. What is the benefit of that is traditionally when we create a cluster and then if we want to have a region to be able to store the data, that means I have to create those regions along the way of my CI/CD pipeline. I have to create a region in dev environment. I have to create a region in QA. I have to create a region in prod. Any way along the line, if I forgot to create the regions manually, and if it's not automated, your CI/CD pipeline or CI/CD practice is going to be not in good state. So one thing is that we want to minimize the need to certain operations. So one thing that Spring Geo starter that bring to you that really helps CI/CD perspective is it's capable of creating a region the moment you deploy the code on deploying the application on the client side, and the server side region automatically gets created. So first of all, to showcase that I have a data I want to push into the server side, I say execute. It's just to show you that region is not there, I'm actually getting error. So now, what if I have a CI/CD pipeline that's just able to deploy the app, right? So for me to deploy app take a couple minutes. So to simplify that, rather than deploy, I'm just going to do a restart. Restart of the app. Simulating is actually doing a deploy, deploy, like first time deploy. So the result is the region is going to be created. But I'm going to show you while it's actually restarting the node. Just going to show you how that configuration actually happens. So in the Spring Geo starter, and by the way, I think during Wednesday for John Bloom's talk about the cloud native application example, that is going to get into more detail. But for me, I just need to have that configurations, and then I have a model defined in the sense that here is my model, and I have a region. Every code, every control, every aspect is on the client side, right? Then I just deployed my applications. As it deploys, as it gets started, my region automatically gets created. I did not run the create region operations. So now, just re-execute my data. I was able to create the data. So this is just like improve the CI/CD or DevOps experience. And I have data model without date of birth. I want to show you that how I can, so my next one is be able to query the data. The second magic is be able to query the data without deploying the models. So I'm going to say query oops. So now I'm able to query the data without deploying the models. Previously, if we say reserialize equal to false, then we're actually going to get class not found exceptions. Right? So now I'm going to give you an example of different data model. Compatibility perspective, I have V1 and V2. The data model is actually different. Is there issues of, do I have to do anything special? So V2, I do not have date of birth. And also, as previously you seen the query, I don't have a date of birth in there. But now in my example, V2 example, I should have date of birth. I should have a date of birth, right? So now let's say I'm going to get the data out. Give me a second here. Create, I have read. Try it out. So customer 1 ID. No problem. I still be able to deserialize the data to the client side without getting any error, even though the date of birth is not there. So I have forward compatibilities. Now, let's say I want to do backward compatibility. I'm going to create a data with date of birth in there. I'm going to try it out. So I have a date of birth in there, and what does that mean in my V1? I'm going to read it out. So the customer ID is C2, is Jen Doe. Not a problem, even if the date of birth is there. And if I don't need it, it's going to be ignored. And what's going to look like on the server side? Going to rerun the query. I didn't have to deploy anything to my server side. How simple that is, right? It's very easy to use. And you have all the control and power to design your model on the client side. So now we show the magic number 3 is data model compatibility. So for the very last one is I'm going to just demonstrating the compatibility between the client and server as the function code. So I don't have enough time to run a full CI/CD pipeline. So I'm just going to be very quickly deploy functions. I have a function over here. And then I have a model over here. I have a constructor in there, and I have string date of birth and all those kind of things. So we already have data in there that doesn't have date of birth. And then it's based on the client-side model rather than server-side model. So I have this functions. It owns its own model. It knows how to translate for the different field into its own attribute. I have one simple function going to display customer informations. So without the need of restarting the cluster, I'm going to just do a very quick deploy. So I'm going to run test build, simulating a CI/CD pipeline, automating of test and build, and that which will create an artifact that allow you to do a deploy. Then I'm going to run another script of deploy. So while the deploy is running, just want to show you what this does. So one of the techniques for Geode CI/CD is to be able to work with the gfish script that you can parameterize and run the gfish command and put it in the script rather than using interactive mode. So by doing that, you can add scripts such as, like, you can say gfish connect to the cluster and use parameterized variables, and then you can run the script. And this can be automated, can put into your CI/CD pipeline. So over here, I run the deploy script, which deploy the function to the clusters and also give some information about what has been done if everything is successful, right? Now I can go back to interactive mode. I can say list of function that gets deployed. And now I can go to my demo. Give me a second here. I'm just going to execute the functions. So these functions, when I insert using API v1 to insert the John Doe, that data doesn't have date of birth. So my function is just say, if it's null, I'm going to say unknown. But I have another data that's C2. Actually has gender that has the data. Now I can actually run my function without getting any kind of serialization issues or class casting exceptions. I'm able to get my data out. So again, it's just make the developer's life much easier, especially allow the engineers to be able to focus on DevOps and improve the efficiency. So just a very quick recap. Serialization magic setup and cloud-ready recipes. Going to close it up. So what's next? In this demo, we didn't get into a lot of depth about how to use Spring Geo Starter, but Spring Geo Starter give you a lot of enhancement from the annotation perspective and how you work with Spring Boot. So that's the session on Wednesday. Make sure you attend that meetings. And of course, there's an event-driven, how the event-driven process can work with the Geo. Right? And if you're interested about more sessions from Pivotal Data TX teams, feel free to join the sessions on Wednesday and Thursday. And I have a lot of example code that's currently on the GitHub. It has an example on how to work with Geo, how to work with Gemfire and Gemfire automations, and also PCC as well. Feel free to go to GitHub, and then if you want to reach out to me, here's my LinkedIn information. All right, thanks. I ran over time.